Here, to find kinetic energy, we know its formula that the kinetic energy is equal to K of E is equal to 1 half mv square. Now we will put the values here. As we know, the m value is already given, so I can write 1 half 6000 and v square as it is, because we don't have the v value. Now delta x1 is equal to 0.50 meter and delta x2 is equal to 0.50 minus 0.30 meter. So we will have 0.20 as a delta x2. We know that the tried car stopped 50 centimeter or 0.50 meter after making contact with the two spring system. Clearly, first spring was compressed 0.50 meter after the first spring was compressed 0.30 meter. Second spring started being compressed. Therefore, here delta x2 is equal to 0.50 minus 0.30, which is equivalent to 0.20 meter. Therefore, second spring was compressed by 0.20 meter. Now, to find out the potential energy of spring 1, so I can write PE1 is equal to 1 half K1 times delta x1 square. Again, we substitute all the values. So 1 half, the K1 is 1600 and delta x1 is 0.50 square, and the answer is equivalent to 200 joule. Now, to find out the potential energy of spring 2, I can write PE2 is equal to 1 half. Now for the second spring, we are having the spring constant K2 and delta x2 square. Let's put all the values. So 1 half, the K2 value is 3400 and delta x2 is 0.20 square, and the answer is 68 joule. Therefore, total potential energy is the sum of potential energy in spring 1 and potential energy in spring 2, which is nothing but 200 joule plus 68 joule, and the answer is 268 joule. Now, equating the two energies, which are potential energy and kinetic energy. So I can write 268 joule is equal to 1 half of 6000 V square. I am writing this kinetic energy because already we have done this kinetic energy in the very first step with this formula. So I can write this one here. Now let's find out the V from this by putting all the values. So I can write V square is equal to 268 divided by 3000, 3000, and we will have the value of V is equal to 0.3 meter per second. So our velocity is 0.3 meter per